Have you ever wondered how batteries power your phone, how metals get coated with gold, or how electricity can actually cause chemical reactions? All of this happens because of electrochemistry, the science that connects electricity and chemical reactions. So, in today's video, I will talk about electrochemistry. Electrochemistry deals with the study of passing an electric current from an electrolyte. An electrolyte is a substance from which the current is being passed on. There are two types of electrolytes, strong and weak electrolytes. An electrolyte which fully passes current is known as a strong electrolyte. Examples are like solution of sodium chloride, hydrochloric acid, and sodium hydroxide, whereas an electrolyte which partially passes current, which is known as a weak electrolyte. Examples are like a solution of acetic acid, ammonium hydroxide, and water. An electrolytic cell consists of a container having two electrodes which are connected to a power source. The electrode which is connected to the positive terminal is known as the anode, while the terminal which is connected to the negative terminal is called the cathode. When a current is applied, the cathode attracts positive ions out of the solution, while the anode attracts negative ions out of the solution. There are different types of cells used for different purposes. For example, galvanic cell, voltaic cell, Nelson cell, Daniell cell, etc. Galvanic or voltaic cells is used in dry cells. Nelson cell is used in the synthesis of sodium hydroxide at an industrial scale, while Daniell cell is used for the production of sodium metal. For today's demonstration, the cell that I'm using here is a Nelson cell. As I said before, a Nelson cell is used for the production of sodium hydroxide. Sodium hydroxide is a strong base, which is also known as lye. It is used as drain cleaner and it is quite popular and common to use in chemistry. At an industrial scale, the basic idea is the electrolysis of a concentrated solution of sodium chloride, also known as brine. Sodium chloride is a non-electrolyte, but when dissolved in an aqueous solution or in a molten state, it is a strong electrolyte. So to demonstrate this, I got out a beaker and added a random amount of sodium chloride until it was fully dissolved in some water. I stirred it up to make a saturated solution so it's ready for electrolysis. So this is my electrochemical cell. This is connected to a battery which acts like an electron pumper. Then I added the solution inside my beaker and plugged in the cell. I waited for a while but no current was flowing, which meant that there was some problem in it. I checked it and it turned out that the whole current was shorting because the wires had leaked and shorted. So I replaced my setup with this one. This time when I plugged in the cell, the current immediately started flowing. Here the reaction happening over here is a redox reaction, where at anode oxidation occurs. Chloride ions are preferentially discharged over hydroxide ions because they are in high concentration in brine. While over at the cathode, reductions occur. Water molecules or hydrogen ions are reduced to form hydrogen gas instead of sodium ions because water is more easily reduced than sodium ions. Left behind in the solution are sodium and hydroxide ions, which then combine to make sodium hydroxide in solution. Overall, the electrolysis of brine results in the production of sodium hydroxide, chlorine, and hydrogen gas as byproducts. So I let the electrolysis occur over the course of some time, and after some while, some green stuff was made, and I think that this is all iron chloride. This is because the metal electrodes that I'm using here is stainless steel instead of inert graphite, which in result dissolves the steel at the anode making chlorine gas, which then reacts with it to make iron chloride. This is not a big deal. Instead, it just makes a separate layer in solution. At the cathode, the hydrogen bubbles produced are highly flammable, producing nice popping sounds. After consistent electrolysis of about 10 to 15 minutes, I turned off the electrolysis. While the electrolysis was occurring, I checked its pH, which was quite basic, meaning that some sodium hydroxide is actually forming. I then removed the electrodes and looking at it at the anode really got eaten up. as the cathode remained just fine. I then separated the layers and as a last-ditch effort, I filtered the solution. I then finally checked its pH and it was definitely very basic, meaning I finally made sodium hydroxide. So I stored it back inside a bottle. I also just for fun added a little bit of sodium hydroxide into a beaker and added some aluminum foil. This resulted in formation of sodium aluminate and hydrogen gas. Well, this was all about electrochemistry. I hope that you learned a lot, and if you like watching videos like these, consider subscribing to my channel and liking my videos, and I will hopefully see you in the next one. Thanks for watching.